Okay, we want to look on number patterns, sequence, and series. So the first thing before we go any further, or whenever, even if you start alone, when you do a certain topic, you must have a full understanding of the general in about the whole topic. Because if you study without knowing what are you studying, it will make you easier to forget. So the first thing you have to understand, what are you studying about? So here we want to do number patterns, sequences, and series. So we want to find out or to define what are patterns, what are sequences, and what are series. Then from there, we're going to look on the relationship on patterns, sequences, and series. Why it is the same topic, and what are the differences, and what are the similarities. Okay? So let's start by looking on the definition of pattern. What is a pattern? So if you don't know what is a pattern, definitely it might be difficult for you to understand this topic. If you don't understand what are sequences, it might also be difficult to understand this topic, as well as series. So let's start by a pattern. A pattern is when numbers are following a certain order, or numbers in a certain order. Okay, so here is the definition. When numbers following a certain order. Okay, so the word patterns and sequences, it can be used interchangeably. So what you're going to do here, I'm going to define sequences, then you go on with patterns and sequences. Then later on, we have to look on series and look what is the relationship between series and sequence. So the next thing, let's define sequence. What is a sequence? Okay? A sequence is when numbers following a certain pattern. Okay? Right, so that is the definition of sequence. Right? So let me bring examples of patterns, then we move with them later on to sequences. So let me list an example of patterns. I'm going to deal with 3 different examples, and I will continue with those 3 different examples. So the example 1, let me say patterns. Examples. Okay. Let me start with 0, 3, 6, 9, 12, I think 0, 3, 6, 9, 12, and so on. Right? Then the next one I can put, okay, before I put the next one, let us define which are these numbers following a certain order, and if they are following a certain order, which order are they following? Okay? So let's look here. If you see from 0 to 3 we are adding 3, from 3 to 6 we are adding 3, from 6 to 9 we are adding 3, and from 9 to 12 we are also adding 3. Right? So this pattern is following an order of adding 3. So these numbers are following a certain order. Which order of adding 3? So therefore this is a pattern. Okay? Right. So let me put another example. Let me start by saying 1, 2, 4, 8, and 16, and so on. Right? That is another example of a pattern. which means to classify that this is a pattern, which means these numbers are following a certain order. Let's see what is the order that they are following. If we check here, I've added 2. If we check here, I've added, oh sorry, here I've added 1. Here I've added 2. Here I've added 4. Here I've added 8. Right? But now, if you see here, each number that is following that you are going to add next, you are going to multiply the previous difference by 2. Then you add, for example, here I add 1, so here to get 4, I'm saying 1 times 2, then I add here to get 4. Right? The same thing here, you have to say 2 times 2 to get 4, then I'll add to 4 and get 8. Then here I'll say 4 times 2 and get 8, then I add to 8 to get 16. Therefore, they are following a uniform order. So this also qualifies as a pattern because those numbers are following a certain order of multiplying the previous difference by 2 and add to the next, or simply just multiply the previous term by 2 and get the next term. It also qualifies like that. As you can see, if I say 1 times 2, I'll get 2. If I say 2 times 2, I'll get 4. If I say 4 times 2, I'll get 8, isn't it? Then 8 times 2, I'll get 16. So you're going to say they are also following an order of multiplying the previous term by 2. Multiplying the previous term by 2. So these numbers are following a certain order of just multiplying the previous term by 2 to get the next term. Okay. So that one is also a pattern. Right? So the last one that I'm going to put there, let me put maybe, let me say 1, 2, from 1 to 2, then say 4, 7, right, then from there I'm gonna add add 1, add 2, add 4, let me say 11, and so on, right? So these numbers, they are following a certain order again, right? Here I have a difference of 1, here I have a difference of 2, here I have a difference of 3, here I have a difference of 4. So if you can see, here the difference is 1, here the difference is 2, here the difference is 3, here the difference is 4. So which means for me to get another number after this, I have to add 5. Right? So it means they are following a recognizable order. So here, if I get a number, I can add with 6, 7, and so on. That's the order they are following. So that's how I can explain them that this one qualifies also as a pattern. Right? So I have these 3 types of patterns, and we are going to deal with these 3 types of patterns until the end of the topic: number patterns, sequences, and series. Okay. So now let's move on to sequences. Right? I said sequences. A sequence, okay, I already defined a sequence when numbers are following a certain order. So now I have these as patterns, right? But now we want to classify them into sequence, right? So each of these patterns follows under a certain type of sequence. Okay? We have what we call an arithmetic sequence. Then we also have what we call a geometric sequence. Then we also what we have what we call a I think quadratic, yes, quadratic sequence. Okay, right? So it means of those types of patterns that I have listed there, each of them, it must fall under a certain type of sequence. It either falls under arithmetic, or falls under geometric, or falls under quadratic. Okay, according to this syllabus of metric. Alright, so now we want to go and look on each and every type of sequence. How do you identify that this is arithmetic? How do you identify that this is geometric? How do you identify that this is quadratic? So that is only biggest issue here. You must be able to identify a given pattern or a sequence into arithmetic or quadratic or geometric. So let me start by arithmetic. How can you identify that this sequence is an arithmetic sequence? Okay? Alright, so let's start by defining arithmetic sequence. Okay? Let me write this here. Sequences. We have one arithmetic sequence, and two, we have geometric sequence, then three, we have quadratic sequence. Okay, so let's start by arithmetic. For you, how do you know that this is an arithmetic sequence? So it is simple. An arithmetic sequence, let me say, is a pattern where there is a common difference between consecutive numbers, right? So let me define it this way. Let me write it here. Something which is, let me write it here, arithmetic sequence. Okay, right. Let me say arithmetic sequence is when a pattern follows, or when a pattern has common difference, right? This is when a pattern that has a common difference between consecutive. Where is my rubber? Where is my rubber? Oh, here it is. Okay. Consecutive numbers or terms. Okay, I'm going to explain the word term. What do you mean if you say terms, right? Okay, so here arithmetic sequence is when a pattern that has a common difference. That's the main thing. So the only thing that makes you able to identify that this is arithmetic sequence is the common difference, right? What do we call common difference, right? Someone would like to ask what is common difference? Okay? Right. A common difference is the difference between terms. That is a common difference. A constant or equal difference between terms of sequence. Let me use the word constant. Difference between terms of the sequence. Okay? Right, someone would ask, what is a term? Now, because we are talking about a term, when I started, I wasn't mentioning anything about term, but now I just explaining using the word term. A term is any number that make up the pattern. Here, 0 is a term, 3 is a term, 6 is a term, 9 is a term, 12 is a term of this pattern. So that is the term. So now, a common difference is a constant. So it means if I have constant or same distance between these terms, it means that pattern is arithmetic sequence. Okay? So let's find out which one is arithmetic here. Let me start with the first one. I have 0, 3, 6, 9, 12, and so on. Let's find the difference here. It's plus 3. Here is plus 3. 9 minus 6 plus 3. 12 minus 9 plus 3. Now the difference is constant, is not changing. Right? So this is an arithmetic sequence. Let's find the next one. Is it an arithmetic? Right? I have 1, 2, 4, 8, 16. Right? The difference here is 2 minus 1 plus 1. 4 minus 2 plus 2. 8 minus 4 plus 4. 16 minus 8 plus 8. Okay? Right? This is not constant. The differences are not constant or are not equal. So this is not an arithmetic. Okay? Let's go to the last one. I want to check again. 1, 2, 4, 7, 11, and so on. Right? What is the difference here? 2 minus 1 is 1. 4 minus 2 is 3. 7 minus 4 is 3. 11 minus 7 is 4. Here again, we don't have a constant difference, right? So as you can see, this of this sequence of this pattern, this one is the only arithmetic because it has common difference. So these ones are not arithmetic sequences. Okay? Right. So that's how you identify that this is an arithmetic sequence. Okay? Then from there, under arithmetic sequence, yes, we have to be able to identify that this is an arithmetic. There is an issue of finding the remaining terms, right? Remember, this sequence is continuously going. So it means you're gonna ask it any time to find any term beyond this, right? So as I said, these are terms. So my term 1 or term number 1 is 0. My term number 2 is 3. Term 3 is 6. Term 4 is 9. Term 5 is 12. So which means I will be able to find term 6. Okay? Right. To get term 6, I have to add 3 to term 5. Right? I have to add 3 to term 5. So it means it might be 15. Right? But now the issue is, what if they ask me term 100? Right? Can I add all of them up to 100? It might be difficult, or they're going to ask me term 1000. Right? So it means we must come up with a formula of Tn. Okay? We must come up with a formula of Tn, any term beyond this. Right? So any term beyond this under arithmetic, it is given by the formula a plus n minus 1 d. Okay? So let's explain what we mean by Tn is equals to a plus n minus 1 d. Right? So Tn represents n term for the arithmetic sequence. Remember, this is term 1 is given, term 2 is given, term 3 is given, term 4 is given, term 5 is given. But you are not given term 6, term 7, term 8, term 9, and so on. Right? So you can use this formula to identify any term of the sequence or pattern that is following an arithmetic sequence. Okay, so Tn is any term of the sequence, right? Then A is equal to term 1 or the first term. Okay? Then N is the term number. Term number, right? Then D is the common difference, which you normally find first when you want to get whether this sequence is in arithmetic or geometric or quadratic, right? So that's how it is. So here now, on our given sequence, yes, we already identified that this is arithmetic. So now let's try to find any term of this sequence. Let's prove it from given terms, right? We said term, let's start with term 4. Term 4 is 9. So let's use this to find term 4. We want to make sure that are we going to get 9 for real, right? So term 4, which means it's term number 4, right? So which means my n is equal to 4, right? And I've already given a is equal to 0, and our common difference d is equal to plus 3. So now we know that Tn is equal to a plus n minus 1 d. So it means here I must find term 4 is equal to 0 plus n minus 1, which is 4 minus 1, multiplied by common difference, which is 3, right? So term 4 is equal to 0 plus 4 minus 1 is 3, multiplied by 3. So it is 9, which is 1, 2, 3, 4. Yes, my term 4 is 9. Okay, that's what you do if you are using this formula to find any given term or any term that you're going to ask to calculate. So let's say maybe they're going to say find term 20, right, which is T20. Okay, right. Tn is equal to a plus n minus 1 d. We already know that our a is equal to